Okay, this is 2.3, polynomials and synthetic division. You're going to know how to do long division, synthetic division, and understand the factor and the remainder theorem. So long division. Long division is just like what you've done before, just like when you were back in elementary or whatever, whenever we did long division. Hold on, let me show you. For example, 3 goes into 210. So 3 goes into 2? No. 3 goes into 21? Yes. 7. 7 times 3 is 21, right? Which is 0. Drop your 0. So this is 70. Remember how you used to do that? It's the same way here. Okay, so we're going to go ahead and divide. So I've got 6x cubed minus 19x squared plus 16x minus 4, and we're going to divide that by x minus 2. So what I want to do is I want to make my x 6x cubed. So I have to multiply it by 6x squared. So when I multiply those, I go 6x cubed minus 12x squared. Now, we're subtracting these, so we just change everybody's sign, and I end up with 7x squared. And of course, this is going to be 0. Drop your next one, plus 16x. Okay, so, sorry, this is a negative 7x squared. Now, I want to make x negative 7x squared, so minus 7x, multiply, I get negative 7x squared plus 14x, and then we just want to subtract everything, so change everybody's sign. 2x, drop your next one, negative 4. So I want to make x 2x, so multiply by 2, and I get 2x minus 4. And again, since we're subtracting, then you're done. So you end up with, that's your final factor. And now you can factor it all the way. So you've got x minus 2 is what you factored out. And when you factor 6x squared minus 7x plus 2, you get 2x minus 1 and 3x minus 2. That's the whole point of using the long division or synthetic, is to get it down to linear factors. Each of these have a degree of 1. All right, go ahead and give this a go and pause, and I'll put the answer up. Okay, here's the answer. All right, so next one, this is just talking about how you do it, you know, how to do the long division and all that stuff. And it just tells you like the way to write it. So this is what you were dividing. So that's your quotient, and then that's your remainder. So this is what you ended up with, and this was your remainder over x plus 1. Okay, so let's go here. We're doing long division. So the one thing you need to be careful of is remember that you've got to take care of every space. So this time we're doing x cubed plus, notice there's no x squared, so we're going to go 0x squared plus 0x minus 1. And I'm going to divide that by x minus 1. So I want to make x cubed, so I want to go x squared, so I get x cubed minus x squared. We're subtracting, so change everybody's sign. X squared plus 0x, drop this one, and then plus x, so I get x squared minus x. We're subtracting, change everybody's sign, so I get x minus 1, so plus 1. Okay, now unfortunately you cannot factor this, so what we would do is say x minus 1 times x squared plus x plus 1. And what that should do is that should equal your original equation. So if I go ahead and multiply through x cubed, this is how you check it. X cubed plus x squared plus x minus x squared minus x minus 1. So what happens is the minus x squareds go away, this goes away, and you end up with x cubed minus 1. So you know you're correct. Okay, this is your turn, so go ahead and do the division and check yourself, and I'll put the answer up in just a second. Here's the answer. Now, one of the things you cannot do is you cannot say this because x can't equal 3 otherwise, because that's one of your zeros. Okay, moving on. Okay, so this next one we're going to start doing synthetic division, and so it's totally up to you on how you want to do it. It's your choice. I personally like to do long division just because I forget. But for synthetic division, all you do is you put in all of your values. So we've got 1 that's in front of the x to the 4th. We've got a 0 for x cubed, -10, -2, and a 4. And what you do is you solve this. So this is x equals -3. So you're using -3. And then what you do is drop your first one, multiply by -3 and add. Multiply by -3 and add. 3, 1. And this is -3, 1. And so what you have here is x to the 4th minus 10x squared minus 2x plus 4 divided by x plus 3 is equal to, now remember you factored out x minus 3, so that means this one here is going to be x cubed, x squared, x, and then your constant. So it's going to be x cubed minus 3x squared minus x plus 1 plus you have a remainder of 1 over x plus 3. So since you have a remainder, that means that it is not a 0 of your function. All right, go ahead and give it a go. Pop on when you're ready. And here's the answer. Since you got a remainder of 0, that means x plus 2 is a factor. Okay, so now we're going to use the remainder theorem. And so with the remainder theorem, what we want to do is we want to see if we actually have a remainder. So if I go ahead and do my synthetic division, 7, and, oops, I told you I'd never do this. Let me erase that. There we go. Okay. I always do the other way. So this is -2, and again, I did it again. All right. Now drop -6, which is 2, -4, which is 1, -2, which is -9. That means f at -2 is equal to -9. So really all I had to do is plug in -2 into this equation and find out what my remainder is, and this remainder should equal that. This is your remainder. Since there's a remainder, that means that -2 is not a factor of this function. Okay, go ahead and give it a go. So what you want to do is just plug them in and see. All right, here's the answers. That means none of these are factors of that original equation. Okay, so we're going to go to this next one here. So what I'm going to do is I'm going to set this up. 2, 7, -4, -27, and -18. And I'm going to do my first one, which would be 2. So 2 is 4, which is 11, which is 22, which is 18. And this is 36, which makes this 9, which makes this 18, which is 0, which means that is a factor. So now I'm going to do it again, and this time I'm going to use, I used 2, now I'm going to use -3, so drop my 2, -6, 5, -15, which gives me 3, -9, which is 0. So this was, let's go back and talk about this real quick. This was x to the 4th. This is x cubed. This is x squared. So what I have at the present time is 2x squared plus 5x plus 3. So I can break these all the way down into my factors. So I have x minus 2, x plus 3, and I can factor this one. So 2x and x, and this is going to be x plus 1, and therefore this is plus 3. So if I had graphed all of these, what you would have seen is I would have a 0 here, I would have a 0 at -3, I would have a 0 at -1, and I would have a 0 at -3/2, which means my function would look something like this. But what it means, since it factored totally down, these are all roots of my equation. Okay, next one's checkpoint. Go ahead and do it and come back when you're ready. And here's the answer.